Unlike bovine leather, camel hide has a denser fiber network and a naturally thicker dermal layer. This is not accidental. It's a biological adaptation, insulation against heat during the day and cold at night, and it's precisely what makes camel leather exceptionally durable and flexible. Historically, camel hides were not raised for leather. They were preserved after the animal's working life used by desert cultures for tents, armor, and footwear. Modern luxury camel leather is built on this same principle, ethical sourcing through secondary use, not industrial farming. In today's industry, only a fraction of camel hides qualify for luxury leather production. Scars, uneven fiber density, or age-related brittleness can disqualify a hide instantly. This strict selection process ensures consistency and explains why camel leather remains rare and expensive. At a microscopic level, camel leather contains tightly interwoven collagen fibers with a higher natural oil content. This structure resists cracking while maintaining softness, eliminating the need for heavy chemical softeners later in the tanning process. Compared to cowhide, camel leather breathes better, weighs less, and ages more gracefully. This makes it ideal for luxury bags, footwear, and garments designed to withstand both heat and friction without sacrificing elegance. Once selected, the rawhides begin their journey into transformation. What arrives here is biologically unstable, prone to decay within hours if untreated. The next stage is not craftsmanship, but chemistry, preserving life's structure long enough to reshape it. In the next chapter, we'll enter the preservation phase, where water, salt, and time determine whether a hide becomes luxury leather or waste. Fresh animal hide is biologically active. It still contains water, proteins, fats, and enzymes, the same conditions that allow bacteria to thrive. Without immediate intervention, microbial activity can begin breaking down collagen fibers in a matter of hours. As bacteria consume residual proteins, they release acids and enzymes that weaken the hide's structural integrity. Once collagen is damaged at this stage, no tanning process can fully repair it. Preservation isn't optional, it's irreversible prevention. The most common preservation method is salting. Sodium chloride draws moisture out of the hide through osmosis, depriving bacteria of the water they need to survive. This slows biological activity without altering the hide's natural fiber structure. At the microscopic level, salt penetrates the dermal layers, binding free water molecules. The goal is balance. Too little moisture removal allows decay. Too much can stiffen fibers and complicate later rehydration. After salting, hides are stacked and left to rest for several days. Gravity and time allow excess brine to drain, while salt concentration equalizes across the entire hide, ensuring uniform preservation. Preservation halted decay, but it also dehydrated the hide. The first step in wet processing is soaking. This carefully controlled rehydration restores the hide's natural moisture balance and flushes out excess salt trapped between collagen fibers. As water re-enters the hide, collagen fibers swell and separate. This physical expansion reopens pathways that were compressed during drying, allowing chemicals in later stages to penetrate evenly instead of remaining on the surface. Natural enzymes are introduced to digest residual proteins, blood, and fats left behind from the animal. These enzymes target non-structural material only, leaving the collagen framework intact. Next comes liming, a high alkaline treatment using calcium hydroxide. This raises the hide's pH dramatically, breaking down hair follicles and loosening the epidermis from the dermal layer. Under alkaline conditions, keratin, the protein that forms hair, weakens and dissolves. This allows hair to be removed without cutting or tearing the collagen beneath, preserving leather strength. Mechanical dehairing completes the process. Rotating blades and rubber rollers remove loosened hair efficiently, leaving a clean, uniform surface ready for refinement. Modern tanneries capture hair and protein waste for reuse in agriculture or energy production. This reduces environmental impact and closes material loops that were once discarded. At this stage, the hide is chemically clean, fully rehydrated, and structurally exposed. What remains is pure collagen ready to be transformed from a temporary biological material into permanent leather. No animal hide is naturally uniform. Muscle zones, joints, and stress areas all produce thickness variations. Left untreated, these inconsistencies would cause uneven stretching, wrinkling, and premature failure in finished products. To correct this, tanneries use precision shaving machines. These machines don't cut leather, they plane it, removing microscopic layers from the flesh side to achieve exact thickness targets. The heart of the system is a helical blade spinning at thousands of rotations per minute. Feed rollers regulate pressure, ensuring the blade removes material evenly without compressing or tearing fibers. As the hide passes through, sensors adjust pressure in real time. Thicker zones receive deeper passes, while thinner areas remain untouched, preserving natural strength where it matters most. Technicians verify thickness down to tenths of a millimeter. For luxury camel leather, tolerances are extremely tight, often within plus or minus 0.1 millimeters across the entire hide. The removed material doesn't go to waste. These collagen-rich shavings are repurposed into composite leathers, fertilizers, or industrial binders, maximizing resource efficiency. Once thickness is controlled, the leather behaves predictably. It stretches evenly, dyes uniformly, and responds consistently to finishing, the foundation of luxury quality. Next, we'll give camel leather its visual identity through dyeing, fat liquoring, and controlled color penetration. Wet leather is vulnerable. As water evaporates, collagen fibers naturally want to contract and bind together. Drying is not about speed, it's about controlling how fibers settle into their final configuration. If drying happens too quickly, the surface hardens while inner layers remain wet, trapping stress inside the hide. Controlled airflow and temperature prevent internal tension that could lead to warping or cracking. For high-end camel leather, vacuum drying is often used. By lowering air pressure, moisture is removed at lower temperatures, protecting oils and preserving softness. Stretching redistributes fiber tension created during tanning and dyeing. This step improves flatness, maximizes usable surface area, and ensures uniform mechanical behavior. As fibers align, the grain tightens. This is what gives luxury camel leather its clean surface, natural sheen, and resistance to wrinkling over time. Moisture content is measured precisely. Too much residual water risks mold. Too little makes the leather brittle. Balance here determines long-term durability. Once stabilized, the leather holds its shape, thickness, and flexibility ready for surface refinement and final performance tuning. Next, we'll perfect what the eye and hand experience finishing, embossing, and surface protection. Before camel leather can leave the tannery, it undergoes its most critical evaluation. At this point, production is complete, but quality is not yet guaranteed. Backlighting exposes natural imperfections, scars, insect marks, or uneven grain density. These aren't flaws to be erased, but characteristics to be categorized. Each hide is graded based on usable surface area, consistency, and cosmetic quality. Higher grades are reserved for visible luxury products, while lower grades are redirected to less exposed applications. Random samples are mechanically tested for tensile strength, tear resistance, and elasticity. These measurements ensure performance matches design specifications. Every hide is traceable from sourcing region to finishing batch. This data allows brands to guarantee consistency and respond quickly to any quality deviations. Packaging protects leather from moisture, light, and compression during transit. Breathable materials prevent condensation, critical for long-distance shipping. From here, camel leather travels globally to fashion houses, shoemakers, and artisans who will transform it once more. In the final chapter, we'll see how this material completes its journey, becoming products built to last a lifetime.